Welcome everyone. Zahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab, Lahore. Today is the 28th day, and we were discussing the time series analysis, the framework for time series analysis. And in my previous session, I have discussed the basic consideration towards the time series analysis. In my previous session, I have discussed how to declare your data set to be time series, then how to create the line graph, how to consider the summary statistics, then Pearson correlation and OLS regression. And after that, I have discussed the unit root testing procedure using augmented Dickey-Fuller and PP parallel test, uh, from where we have calculated some values in our procedure. So today I am going to discuss uh, the hypothesis testing using a simple model, which is known as ARDL model. Because in order to apply the simple regression or OLS regression, you need to understand that your time series analysis will indicate that your dependent variable is stationary at level and independent variable is also stationary at level. When both of your DV and IV are stationary at level, you are going to apply the simple regression or OLS regression. But when your dependent variable is stationary at first difference, while your independent variable may be stationary at level, may be stationary at first difference, or may be stationary at second difference as well. So we may consider independent variable as a mixed stationary. And you also need to understand that if your dependent variable is stationary at first difference and your independent variables are also stationary at first difference, in that case, you can also apply the ARDL model. So, in order to apply the ARDL model, there are two conditions. In both of these conditions, your DV should be stationary at first difference, and your IV may be stationary at mixed difference or maybe stationary at first difference. In both of these cases, you are going to apply the ARDL model. So let us consider this regression, this unit root estimates, as you as we have discussed in detail, that how to estimate unit root testing. If you see here, the first column of the ADF part indicates the unit root at level. There is a question if our DV first or zero stationary and IV second difference, then which model ARDL? Use ARDL. Basically, as per the procedure, if you see here, this is the framework. If your dependent variable is stationary at first difference and your independent, some of your independent may be stationary at zero or some of them stationary at first level or at second level, you can apply ARDL. But as far as your question is concerned, I didn't get your point. If our DV is first or zero stationary, you are asking that if our dependent variable is stationary at zero level and at first level, yes, still we can apply the ARDL. We need to see only the independent variable. If independent variable is stationary at mixed or independent variable is stationary at first difference, then we can apply the ARDL. So this is the basic consideration. So let us start from this table. If you can see, uh, in this table, FDI is the dependent variable, while these are the set of independent variable. For example, financial development, uncertainty, capital formation, sustainable economic growth, GDP growth rate, GPT per capita, trade openness, inflation rate, exchange rate, and real growth rate. So these are the independent variables. And the first one is the dependent variable. If we see here, the dependent variable is showing stationarity at level as well as at first difference using both method. If you consider the ADF method and if you consider the PP method, both of it, both methods are showing that your dependent variable is stationary at level as well as at first difference. So the first condition is met. The second condition is that your independent variable should show either the first level stationarity or the mixed stationarity. Mixed mean it may be stationary at level. Some of the variable may be stationary at first difference. Some of them may be stationary at second difference. For example, if you can see the financial development, which is the first independent variable, it is not stationary at level. It is also not stationary at first difference, but uh, it is stationary at second difference. So we can say that here the first independent variable may be stationary at the second difference will indicate a mixed stationarity for all the independent variable. If you see the other independent variable, for example, uncertainty, sustainable growth, capital formation, GDP growth rate, GDP per capita, trade openness, inflation rate, exchange rate, and real growth rate. All of them are stationary at first difference using both methods. So we can indicate here a mixed stationarity here. So whenever your condition is fulfilled, it means if your dependent variable is stationary at 0 as well as at 1, and your independent variables are showing you mixed stationarity, it means you are going to apply the ARDL model. So let us start the procedure from here. So I have designed a step-by-step procedure for considering the ARDL, but before applying this procedure, I want to discuss with you some important articles. These are some articles that you need to consider for understanding the step-by-step procedure. For example, this is the article. It is very easy to understand article. There may be some other articles as well, but for me, this article was very easy to understand, the ARDL procedure. So it is the study which is based on energy growth nexus. If you can see here, I would like to show you the methodology. Here they have discussed that after stationarity, the first step in the ARDL process is the unit root analysis. So as I have discussed with you, to satisfy the bound test assumption of ARDL model, each variable must be either stationarity at 0, 0 means level, or it may be at first difference. Under no circumstances, it should be at second difference. So it means that your stationarity may be mixed under no circumstances. So this is basically the basic co-integration model. And if you want to see here some other considerations, uh, there is a procedure which is known as co-integration. I will let you know. This is also the part of the RDL process, and there are some assumptions that after estimating the ARDL, you need to confirm these assumptions. I have made a list of these assumptions like serial correlation, heteroscedasticity, normality, functional form, and multicollinearity. These are some of the assumptions that you can apply as a diagnostic test after co-integration or after ARDL procedure. So, as a matter of fact, or as a understanding the step-by-step procedure, I would like to show you something from another paper. This is another paper. You can study this paper. It is written by one of my students, Maria Ashraf. She has done this paper with a collaboration as a collaboration with me, but due to some reason, my name could not be appeared here as a author. So basically, this study was done by me, and this is the first step where I have shown the FDI trend. You can see here the other independent variables here. So first of all, I would like to show you the model. This is the model. There are two independent variables. There is one dependent variable. This is the theoretical model. And as far as the methodology is concerned, this is the model. You can see here it is the simple time series model. So uh, when you are using a macroeconomic data, always try to convert your variable into log terms like ln uncertainty, ln financial development. So I have converted my variables into log terms. Then I have converted my model into ARDL model. So ARDL basically contains two types of estimations. The first one estimation is known as long-term estimation, and the second one is known as short-term estimation. So when you are considering the long-term estimation, you need to convert your model like this. And this is basically the short-term estimation. uh, the sign, the basically delta sign here. You can see here the delta sign. So this is the short-term estimation and this is the long-term estimation. So it is the procedure to run the model. So as a first step, uh, after creating the line graph, you can consider the descriptive statistics like mean, range, minimum, maximum, and count standard deviation of your variable. Then you can consider the stationarity. If you can see here, this is the stationarity using ADF and PP. So there is a very weak stationarity at level or at zero level. But if you see the first difference, there is a very strong stationarity using both of the methods. So whenever your DV and IV shows stationarity at first difference, it means you are going to use the ARDL model. So this is basically the starting point for ARDL modeling. The stationarity testing or unit root testing is the starting point. So it will let you know whether you are going to use the ARDL model or not. Then you will consider the optimal lag selection. It will let you know how many lags are basically required. So in order to decide how many lags are required, you need to see AIC or HQIC and SBIC criteria. And if you see steric sign, in which rows, that is basically corresponds to your lag length. So as you can see that using these criteria, you see steric sign on the fourth row. It means there are 4 lags required using this data. So as a part of it, you will also consider the co-integration. Co-integration is basically a procedure in order to understand whether there is a long run relationship between the variables or not. So it will testify the long run relationship between the variables. So we need to see the critical values. For example, here the F statistic is 12.306. So we need to compare this value with lower bounds and upper bounds. LB stand for lower bounds and UB stand for upper bounds. So this value should be greater then lower bounds and upper bounds values at all critical levels. If it is greater than these critical values at all levels, so we can say there is a long-term relationship between the variables. But if your F statistic value is less than lower bound and upper bound values, we can say that there is no co-integration between the values. So always remember that whenever we find no co-integration, then we need to change the method of estimation as a part of ARDL process. So there was a line that I have highlighted here. Yes, this one. So when no co-integration is confirmed, we can proceed with. All right, there was an interruption in the internet. I was telling you when you found no co-integration, then you can proceed with Granger causality test uh, of unrestricted var. But if you find co-integration, then you can proceed with your ARDL process. So I have basically simplified this process of ARDL. As a first step, you need to consider the line graph. So let us start from the data that I have shared with you uh, with both of my participants. So let me open the Stata file and we will start the procedure of ARDL process. Let me open from here. Yes, this one. This data is being shared with both of the participants. It contains the FPI, the log value of your economic uncertainty, and financial development. There are two independent variable and there is one dependent variable. So whenever you need to apply the ARDL process, the first thing that you can do is to consider the line graph. So what is the command? That is line, variable name, and then your time dimension. So here the time dimension is years. First of all, I need to declare my data set to be uh, First of all, I need to declare my data set to be time series. I need to remove some of the unwanted variables from here first, like this. So let me declare my data set to be time series. So the first command is ts set years, year, because my time dimension is years here. So this is the declaration that the data set is time series. Then after doing this, what we need to do uh, the next thing that we can consider here is to consider the line graph. Right. Now you can put here your variable and then your time dimension, which is years. So it will estimates the trend line for your variable because here the FDI inflow is the dependent variable. So you can see here that the highest FDI was reported in the year 2005 and the lowest FDI was reported in the year 2014. So it started increasing again afterward. So it is the trend line. You can consider the same command for other variables too. Like for this, you can put here years. So it will show you that your log of your economic uncertainty is basically increasing with the passage of time. So in the same way, like your third variable, which is financial development, years. So you can find here the financial development is also increasing for this particular data set. So the second thing that you can consider here, but before considering this data, uh, the second thing that you need to do is to descriptive statistics. So it is the simple command that we have also discussed yesterday, sum all of your variable like this, and you will find out the descriptive statistic. There are 20 number of observation. The mean financial development FDI inflow is 2.09, uh, and log of EUP is 5.16, LFD is 5.21, and so on. You can find here the basic descriptive statistics. Then, as a third step, you can consider the unit root test. There are a lot of criteria here that we have discussed yesterday. We can still apply the manual procedure. You can go to the statistic, time series, test, and from here you can choose augmented Dickey-Fuller. You can choose your variable, for example, FDI, go to time series and select yearly, click on OK. And from here, you need to select the include trend terms and click on OK. So it will let you know that your dependent variable is not stationary at level. You can see here the test statistic value and their p-value is not significant. And this test statistic value is less than the critical values at all levels. It is less than the critical value at 1%, at 5%, and at 10%. So we can say that your FDI or your dependent variable is not stationary at level. Now, we can check it. We can check the same command at first difference. For example, we can put E dot before it, and we can find out here that your dependent variable is basically stationary because it is statistically significant, and this value is also greater than the critical values of all levels. So the first condition for the dependent variable is fulfilled. We can say here that your DV is stationary at first difference. First difference. And technically we can write here like this, I1. So this is stationary at first difference. Now we need to see that our IVs either they may be stationary at first difference or they may be mixed. Mixed or first difference. Mixed mean they may be, some of them may be stationary at level and some of them may be stationary at first difference. So we can verify from here. We can run the same command and we can replace the variable names from here. The second independent variable, the second variable, which is independent variable. So we can see here, this variable is also not stationary because it is not significant and it is less than all other variables, all other levels. So we can create its first difference. We can repeat the same commands here and we can put here d dot. We can run this command and you can see here, it is stationary at first difference and it is greater than all levels here. So we can see here that it is stationary now. So first IV is stationary at first difference, EUP. It is stationary at first difference. Now we need to see the other variable, which is LFD, which is the log of financial development. So we can put the same command here and we can replace the variable name from here and we can run it. You can also verify that it is not stationary at first difference, at level. Now we can run the first difference command for it. So we can add here d dot. So you can see here, it is still not stationary. So we can run the second difference command, T2. It is not still stationary. Maybe it may be stationary at some other level. So we can consider it as a mixed stationarity. So the next thing is optimal lag selection. It will let us know that how many lags we can select for our ARDL estimation. So always remember that you can take all of your variable DV and IVs at the same time. You can take untransformed or transformed variable. You can place 2 for max lag in case of annual data, and 8 in case of quarterly, 24 in case of monthly data. So what we need to do, we need to write var SOC, then we can put our variables, then comma, then max lag, and then blank bracket. So var SOC, then we can place our variable like this, then comma, then max lag, then blank bracket. So we can run this command, and you can see here that the maximum lag, which is located using AIC, HQIC, and SBIC criteria, because the steric signs are appearing in front of 4. So we can say that the maximum lag length for running the ARDL estimation here is the 4 for this particular estimation. So maximum lag length has been declared. So always remember, in case if you are using an annual data, the maximum lag that you can take is 2. So you can take here 2 as a lag, because most of the researcher has described, for example, the Wooldridge has described, the Gujarati has described that the maximum length in case of annual data should be 2. If you are using quarterly data, you can take 8 as a maximum lag length, 24 in case of monthly data. So this is some suggestions from the renowned researcher that you can consider. The next thing that you can apply is the co-integration test. Co-integration test is basically used in order to confirm whether there is a long run relationship in our model or not. So it will let us know whether there is a long run relationship in our ARDL model or in our time series model or not. So the first thing is that you need to confirm whether your ARDL command is basically installed in it or not. So SSC install ARDL. It will confirm whether the ARDL command is installed in your system or not. So before applying the co-integration process, you need to install the ARDL command, which is autoregressive dynamic lag regression model. So it is confirming whether the command is already installed. As it is already installed, so it has mentioned. So what we need to do, uh, the first thing that you need to do is to run the ARDL first. So ARDL dependent variable, independent variable. So we can run here ARDL. This is the basic command. So after putting your DV, you can put your IV as well. So run it. So it will show you some results. For example, you can see here the model is statistically fit. The R square is approximately 91%. The adjusted R square is 77%. And you can also verify that the second lag of your FDI is basically impacting the FDI. It means uh, the FDI is being impacted by its 2-year previous value. because sometimes your dependent variable may be influenced by its own previous value. So here you can say that the 2-year previous value is basically impacting the dependent variable. Then this is the independent variable. Here you can see the level value without any lag is basically significant here. It is negatively influencing your dependent variable, which means your FDI. Then you can see here your financial development. Financial development is significant, positively and significantly impacting your FDI at first lag, but at second lag, it is negatively influencing. So you need to verify your hypothesis. As the base hypothesis with this study is that the financial development will positively impact the FDI. So we can consider the lag one impact here, which is positive. So the second thing that you need to do is you need to run the ARDL command with error correction. So we can run the same command, but put the comma and EC. EC stand for error correction. So it will correct the error automatically in this model. So you can see here, there is some adjustment in this model, which was not previously mentioned. They have adjusted the FDI at first lag. Previously, if you can see here, you are seeing that at first lag, the value was not significant. But after adjusting the error, it has considered that the first lag value has become the significant one. So we can see here that your dependent variable FDI is basically influenced by its own previous value. So then the long run impact, LR stand for long run and SR stand for short run. So in the long run, if you can see here, the EUP is negatively and significantly impacting, but financial development is positively, but not significantly impacted. You can see here the p value is not significant in the long run. In the short run, if we see here in the short run, the FDI is positively impacting in the short run, and it is weakly significant. And you can see here in the short run, the EUP is not significantly impacting, but financial development is significantly impacting at lag difference. So this is the second step. After doing it, now you are going to run the EStat bound test. So EStat B test. B test stand for bound test. So it will let us know whether there is a co-integration in the model or not. So how can we verify that whether there is a co-integration? You can see here there are two parts of this test. The first part is basically relevant to F statistics. The second part is relevant with the T statistics here. So always remember that you can take any criteria, any decision criteria, you can take your decision based on F statistics and based on T statistics. If you are considering the F statistics, then your decision is based on the first part of this table. But if your decision is basically considered on T statistic, then you can take the decision on the second part. So let's suppose we consider the F statistic criteria based on the first part. Here you can see IO and I1. So IO means lower bound and I1 means the upper bound. So you need to verify that this F statistic should be greater than the lower and upper bound at all levels. These are the levels. These indicates 10%, 5%, 2.5%, and 1%. So you can see here the F statistic value is greater than lower and upper bounds at all levels. You can also verify that your T statistics is also greater than lower and upper bounds at all levels. So it means that your relationship is long term. So we can say that there is co-integration in the model. So as the time for today's meeting is going to end, so we will consider the remaining part tomorrow. So do you have any question, Vakar, for today's discussion? All right, so we will discuss the remaining part tomorrow. So thank you very much for joining. Stay blessed.